All right, so let's hack the game Wordle today rather than machines in the try hack me or hack the box platforms. It is fun more than a challenge. And I've tried to put together some Python codes to help me guess the word as early as possible. Well, it's a guessing game. You are given you need to guess a word in the dictionary. It has 5 characters, and after every guess, you are given some feedback. And the feedback, as it is color coded here, it's such that if the character of the word in your guess, if it is gray, it means that that character here it is T. It is not in the word at all. If you have yellow for that character, it means that your guess for the character is right, but it is at a different spot. It's not at the right point. And if it is green, that means you are right that the character exists and it's on the correct spot. This is the rules of the game. Um, what I've done as start is I first went to this GitHub um, address and downloaded this dictionary called words.txt. It is a 4.64 megabytes document. If you view the raw data here, a lot of words. I downloaded that and processed it. And the way I processed the dictionary is such that I read the lines and I created a list called 5 letters. So I need to extract the words with 5 characters out of the full list. Um, I have two ifs. I have two conditions in the if statement here. One is the length. So I'm having a for loop for the entire words list, and if the length equals to 6, I kept it, and I wanted to keep it. So the reason I have 6 in here is I can call the function and show you the output, and I have this file called words.txt here in my um, Visual Studio directory. All right, and if I run it, you will see that we have 5 characters here and then a new line character. So /n is a new line character, and it is 1 character. So we have 6 as length, including the new line character. That's why it has 6 here. And I use this is alpha so that I'm excluding the characters that are numbers or symbols. So I'm only looking at the alphabetic characters here. So if 2 conditions are met, I am appending that word to the 5 letters list, and I'm giving a name to the list. So I'm just slicing the last 4 characters here. So words.txt is sliced to words, and then I append this part to the file name, and that becomes the file name that I've saved the words with 5 letters, 5 characters, and this is the txt file. So this is the list after excluding words not with 5 characters or words with numbers and abbreviations. Now, that's what I did as start. Okay, and I have this function called towards the end in my main function. Let me show to you. Let me clear out all output. Okay, if I go to the end of the package, I'm calling this 5 letters function inside my main function here. So the process will take place there. Okay. Now, once I have the dictionary ready, the next thing I wanted to look at is where to start. So which words should I start with? To do that, I perform the frequency analysis. So I basically call the uh, dictionary, so the words library, let's call it, and then made a large string by joining the individual words, and then I generated a dictionary, and I can show you there are 3 methods to do that, or 2 methods to do that. First method is I define the dictionary I as the key, which are the characters, individual characters, and my string count as the values. So I'm basically having the names of the characters A, B, C, D, and values for these keys are the counts, the numbers that they take place. I can do that using a dictionary, or I can do it using this counter, calculations library counter method. So if I use the dictionary method, I need to list the items and sort them. Here I can use a lambda function to show the values in decreasing order. Or I can call the collections library and call this counter method on my extended string, and I can have this most common method to list down the top characters. And if I do that, I will get new line character as the most commonly used character because it's used in all words. Basically, this tells me that we have 21,552 words in our database. And next, or the first most common character is A, more than 12,000 times used. E is more than 10,000. SIOR. One thing I need to mention here is that starting with these commonly used characters is a smart approach. So I can start with A, E, S, I, O. But if I enter it, the code will not accept it because this is not a word. So I need to be inserting actual words existing in the dictionaries. So I cannot just list down the top commonly used top 5 characters. So what I need to do then is I first generate a list showing the most commonly used characters, starting from A all the way to U. And then I had a function called first word. This first word function is very straightforward. It's basically looking at the top, such X is 5, first 5 characters and looking on this words database and see if we can create a word out of these 5 characters. If we cannot create a word out of these 5 characters, we will increase the x by 1, meaning that we will consider the top 6 characters and then top 7 characters. And I will stop this process on this while loop when we have a list of 15 words as first guess words. And I can run over here. So basically, because saying that if I can try these words, I am increasing my chances of finding the characters, because these are the words generated using the most commonly used characters, letters, right? Um, and I think this part is maybe confusing. Again, I have to mention here. So in the if statement, I am taking the word I from this my words database, 21,951 words. I'm taking one of them here, or I'll take it one by one, so for loop. I will first convert it to a set. And the reason I convert it to a set is very simple. The word, let's say apple. This word has 2 p's. So if I convert it to a set, and if I look at the length of the set, it will show as 4. Even though it has 5 characters, 2 characters are common, and in the sets definition, you need to have in the new or different elements inside the set. And same with glass. If I change this string glass to set, the length will be 4 because we have 2 s's. Well, the reason I set it to 6, again, first of all, I need to get rid of the new line comment, so it is really 5. But I would like to have words with 5 different characters, so that I'm using more of the characters in the alphabet, so I'm increasing my chances of getting the right word with fewer tries. You may disagree, but that I thought will be useful or reasonable approach. And here I'm having this index range from 0 to x as 5 in the beginning. Once I finish the loop, I increase x by 1. So I'm looking at the first 5, first 6, first 7 characters. And once I have 15 words to start with, I stop it. So basically, I'll be using one of those 15 words. In fact, we can start now because I can show the rest while working on this problem. So out of these 15 words, if I start with, let's say, race, RAISE, and enter it, I had a very good start. So I had 3 letters that don't exist in that hidden word, and A here is the letter A is correct, but it is not the second letter, it's somewhere else. S is correct, and it is the 4th letter of the word, right? That's a good start. Now, I have 3 functions: gray letters, yellow letters, and green letters function. I'll talk about this, but basically, what I'm doing in this code is I'm starting with this with one of these 15 words that I believe is a smart approach to start with. Once I have this complete, I am filling in some of the gaps, and the first gap I'm filling it is about the yellow letter. So I'll explain that to you, but basically I need to come here and I will need to correct this if statement here. So on this word, the first index, which is the second element, right? It's first index. So first index is index number 0, second index is index number 1. So the second element should not be an A. So A will be in the new word, but it is not on and the second letter. So this part, I'm fixing it first and then running the code. And the first question is enter yellow letters. So yellow letter is A. I type it and enter. Enter gray letters. These are R, I, and E. R, I, and E. Enter. And then enter the first letter. So I'm now enter the first letter is read the green letters. And I will tell you why I'm doing it separately for the green letters. Because in green letters, um, I need to be thinking about like enumeration, meaning that I need to think about the right character at the right spot. So I need to clearly uh, enter the characters and their location or index number on the word. So for the first letter, I have no idea. I just click enter. Second letter, I don't know about that too. Third letter, I don't know about that. And fourth letter is an S. I know it's green. And the fifth letter, I don't know. So enter. Okay. So once I run this, here is the feedback I get out of this first word. So we had 21,952 five lettered words to start with. And if I eliminate the gray letters, so if I exclude the words, including R, I, and E, I will have left out with 5,504 words. Awesome. And then if I consider these yellow letters, meaning that I am looking at the words that have at least one A, they may have more than one A, letter A, but that A should not be the second character. And after doing that, I have 1,906 words left. Finally, when I considered green letters, which is I'm excluding all the words not having S as the fourth character, I have left out with 88. Well, that's awesome. Out of 21,952 letters, I have left out with 88. This is a perfect progress. I was lucky in that. Now, I'll go with my second guess. And the second guess, I will try to use the words I have not used at all. So, okay, so this class or blast, maybe something or coast, I can use that too. It's really just guessing at this point. I will just try coast. Right? C-O-A-S-T. Well, that makes sense. I know S is here and I know A is not here. So I'm just changing the spot of the A, keeping S there, and I'm introducing C-O-T. These are all new letters. So that's good enough. And I enter it. Okay, wow. I just, I think, nailed it. Well, so after that, I have no change on the yellow letters, so I won't be fixing this part here again. I'll just run the code one more time and enter the yellow letters. So A is the yellow letter I have here. Gray letters, I had R, I, and E in my first trial, and then O and T in my second trial. I'll click enter. So the first letter, I know is, so the first green letter is C, I know that. The second green letter, I don't know, so I skip, I click enter. Third letter is an A, I know that. Fourth green letter is an S, I know that. And the last letter, I don't know. And once I run that, I have 5 words left to guess. Well, chess, clash, class. class, they all can be good candidates. Let me think and see. H S M. Okay. I can try class just to see as my third attempt. So by doing that, um, I'm having so I'm by doing that I'm introducing a new letter L and another S. I know it may not be the best word, but let's give it a try. Okay. Uh, no, no progress basically. I just get the same output. So um, if I run the code with the new output now, yellow letters, no change. So basically, it's just A. Okay. Gray letters, I had R, I, E, O, T, L, S. So the order doesn't matter because when I show you the functions, I have three functions, yellow, green, and gray. On these functions, I'm always dealing with sets. So when you are dealing with sets, there is no indexing anymore. Set is I'm sure you're familiar with the mathematical definition for set. It is not an index dependent, let's say, quantity or concept. So R I E O TLS. Okay, oh, that's good. And first green letter is a C, I know. Second green letter, I don't know, just enter. Third green letter is A, I know that. Fourth green letter is an S, I know that. And the last one, I don't know, so just click. Oh my gosh, I have zero words, number of words after considering. Wow, that's weird. Um, I have two possible explanations for that. Number one is I made a mistake when I was typing in the input, and I'm sorry if I did that. Number two is that the dictionary that I'm using is not the same with the dictionary that this wordlegame.org is using. And I've had this issue with this New York Times Wordle game, but I didn't show it over here because you can run it every 3 hours, and I want to use it constantly. So I just put this wordlegame.org. So I have two explanations for that. But I can now restart the game with a new word because I don't think that there's something wrong in the code because I tried it many times. I think it's the dictionary that is different between the uh, one I'm using versus the whole game. So I will just restart the game very quickly. And if you're on lack of time, you can quick stop the video. I'll just do it very quick. So the first 15 words I have here. So I can start with which one? I know there are some words are not. So how about this? It looks Greek to me. Oh, yes, I'm sorry. Let's see if that exists. Okay, so that, you see, this word is in my database, but it's not in the database of the Google game. So there's a dictionary database uh, incompetency here. So um, I can, Rosie is a name. So how about this one? S-A-I-R-E. You see, again, I don't have the same dictionary that they have. So A-E-S-I-R. All right. So this dictionary, the program accepted. All right. Now, um, I, okay. So I have to accept whatever is there. So if I have this case where I have no yellow letters, I need to modify the code slightly. And what I will do is I will comment this out completely. And yellow list that I'll be using is this here, yellow list, because I actually yellow is modified. Okay, so let's run the code. All right, yellow letters, I have nothing. So gray letters, I have A, E, S, I, R. Enter, and no green letters. I have a bad start. All right, now looking at that, out of 21,952 letters, I've left out with 1,007 of the gray letters eliminated. I don't have further elimination due to green letters because I don't have any green letters at all. All right, so I can't really uh, add up to that elimination process. Makes sense, okay. Now, the next I can try this word here, block. B-L-O-N-D. I'm sorry, block. I had blonde here, so doesn't matter. I can try blonde. All right, I'll try blonde. Enter. Good. So once I do that, so I need to go back to my uh, Control K, Control U. I commented out and yellow list modified. Okay. Now, what I have to do here is that word is zeroed, the index number with 0 will not be a B, or word index number 012 will not be equal to and O. Okay. I think it's O. All right, so now I can run the code, and yellow letters, I have B and O, enter. Gray letters, A, E, S, I, R, L, N, D. And unfortunately, I don't know any green letters so far. All right, so out of this 21,952 letters, once gray letters are considered, I have 334 left. And with the yellow letters, I have 50 left. And I don't have anything more to filter out due to green letters because I have no green letters uh, captured yet. All right. Now, so I have 50 words left in my dictionary to use here. Which one? Jumbo. That looks interesting. J-U-M-B. And okay, I think it's a good word because J, U, and M are new words. B is in a different spot, and O is in a different spot. Jumbo is, I think, is a good word. I enter over here. Oh, there you go. Perfect progress. Okay. I think I won't be changing anything on the yellow side, but I just need to run the code one more time. And yellow letters, B and O, enter. Gray letters, A, E, S, I, R, L, N, D, and J. These are gray letters. And first letter, first green letter, I don't know, click enter. Second green letter is U, I know it. Third one is M, I know it. Fourth one is B, and the last one is O. All right. Now I have 4 words to guess from. Bumbo, gumbo, humbo, and mumbo. Well, to me, none of them are really actual words, but it's not my native language, so I don't really know what to do. So, um, gumbo. Why don't you try gumbo? There you go. Awesome. Well, I was just lucky on this last guess. So Here I had four guesses, and the first one you can disqualify. It's just random guess. So we have one random guess and three educated guesses, and we were able to get this out. And in the first attempt, I had zero as the recommendation by the code, and I think it's most likely due to the incompatibilities between the dictionaries that I'm using. So the one I'm using is from a GitHub. Here I showed you. And the one they are using, I don't know which one they have. It will be a good idea to use the same dictionaries to uh, for consistency results. Now, I haven't discussed with you the functions that I'm really calling here. So in my main function, I'm asking the user to give me input for the yellow letters, gray letters, and green letters. So yellow letters and gray letters, the order is not a problem, and you can enter the letters more than once, doesn't matter, because I'll be converting them to sets, so it won't change anything. But for the green letters, as the input from the user, I need not only the letters themselves, but also the locations of those letters in the word, because green letters means that my guess for the letter is correct, and I also have the right spot. I have to specifically give the right index number. So I'm having a for loop here and getting the input and appending it to the green letters string. All right. Now, these are really my uh, outputs from those functions. So let's go to those functions. So the functions that I'm using are gray letters, yellow letters, and green letters. So yellow letters and gray letters are easy because I don't worry about index numbers for both. And if you look at the two here, the only difference is the colors that we are using basically. So what we are doing, and there are other differences, but they're minor. Um, what we are doing here is that we are generating a list, and this gray list means a list of the words filtered uh, with respect to the gray letters, basically. So I'm taking this gray letters, so the gray letters that the user is inserting after every guess, first changing it to sets, and then I'm having a for loop for the word list. And for the gray letters, I'm using the complete data set. And I can show you over here. When I'm running the gray list, I'm calling the function using the complete data set. But when I'm calling the yellow list, yellow letters function, I'm using the gray list, which is complete list filtered out after excluding the words including gray colored letters. And for the green letters function, I'm using the yellow list modified with respect to two things. One is this yellow letters filter that I will talk in a while. Also, the uh, for loop here, which helps me to make sure that I'm excluding the words that include this yellow character in the wrong spot. Right? And going back to this gray letters, once I am going through the list, I'm looking at the intersection. So if there is no intersection, so the Boolean operation will give us a false. If there is no intersection, I will append it. Right? Um, and let me hold on. If not, gray letter sets. Okay. So two false cases will make a true statement here. So if there's a true, so this not and this false here will give us a true Boolean outcome, which will then help me to accumulate the gray list. Right. For the yellow list, it is the opposite. I'm in my if statement, I'm just looking at these yellow letter sets to be subset of the word list that I'm using, which is filtered out with respect to word list. Now, in the green letters function, I'm doing more or less the same thing. What I'm doing extra here is I'm putting a counter here. And this counter is looking at the uh, characters in the word list or the characters of the word that I selected from the word list. And it is comparing to the input the user gives after each trial. If the index numbers of the characters are matching, then I increase the counter by 1. All right. And if I have the counter number equal to the length of the uh, characters or length of the or if I have the counter number equal to the number of the green characters, then I append it to my green list. That's the only thing I do extra here. And the reason I do it over here is because for the green letters, I not only look at the character itself, but also the location, and it has to be on the correct location. So with that taken into place, I will have the correct final answer. All right, so other than that, I guess that's pretty much what I'm trying to do over here. Well, it is not a complete standalone Python solution, and in fact, I'm just working on it to improve my Python skills. But it helps me to make educated guesses by using the outcome of the previous trials, and I've enjoyed working on this. Thanks for your time.